I'm Priyanka, and I work on the OpenTracing project. I also head open source and partnerships at LightStep. So some of you might have heard my keynote yesterday. How many people were there? Okay, a good number. That's cool. So you already have a little bit of an intro to distributed tracing and open tracing. However, for those who were not there, I'd like to go over a brief overview and discuss the need for distributed tracing, where open tracing steps in, and then follow that up with the Donut Salon demo if people are still interested, those who have not seen it, and then move on to a discussion around how would end-to-end tracing look like with Kubernetes, where it was zero touch. So that's the plan for the talk, and at the end, we'll be happy to take questions. So this is the recap part. What is tracing and why care? At the core of the concept, distributed tracing helps you know where transactions are going throughout your system across process boundaries. And this helps you create a visual or mental map of what's going on in your distributed system. You can think of it as an action replay. From the perspective of a request, the question is, what happened to the request in each service and how that connected across different services? So distributed tracing really comes into focus when you're dealing with a lot of concurrency. When somebody starts an MVP basic project, they might not see anywhere they're doing the simple and efficient thing for the hackathon to get that project out ASAP, right? Slowly, let's say that app like My Donut Salon app started getting popular. Then you start introducing a little bit of concurrent processes because you want to move faster, you have more of a user load, etc. And then as things get more complicated, you get to async, and then finally distributed concurrency, which you see on my left. So I guess you're right? Yeah, on your right. So the red dotted line and dashes is the path of a single request as it's going through. And this is the visual that distributed tracing can afford you. Now, all that's great, but why is this useful? As we discussed in the keynote, developer workflows are changing. As applications are modernizing, they're able to deploy faster, things are able to scale out better, and there are lots of other benefits. But the problem that comes along with this is that the tooling that the monoliths enjoyed is breaking now. So if you had complete observability into a monolithic structure where you could quickly go and pinpoint a problem, suddenly that's not true anymore. Mean time to resolution is rising because how do you resolve something when you don't know what it is and where it is? And that's what the same story is root causing an issue. And we all know it's much harder when it's 2 a.m. at night. So that's the problem part. And this is where distributed tracing becomes useful. And so tracing is super valuable. Companies have done it for a while now, but it's not been ubiquitous. And we touched on this in the keynote as well. But to go a little bit deeper, which is, to me, the value of this session, there are specific issues for companies looking into a technology like tracing. By the way, in this talk, I used the word tracing so many times. I apologize for that. I couldn't find a good synonym. It would change the meaning, etc. Anyway, so yeah. So first off is the auto instrumentation option, right? Ironically, I'll be talking about that in a Kubernetes environment towards the end of this talk. But at the moment, that doesn't give you the kind of visibility you need in a custom system. Each distributed system is a special snowflake. And to the developers working on it, it's extra, extra special. And every business is also different. So the business metrics and values are not the same. So auto instrumentation, it's too magical. And it doesn't give you the exact things you need. And I hear this every day from people who use our API spec. The other thing is there are APIs for tracing in different languages. There's like log4j and all of that. But the value of tracing is when you can see across your entire system, across processes. How many of you here have a distributed system in one language only? Okay, a few hands. And how many of you have more than one language in your system? most of the room. Exactly. So if you only saw part of the system, again, it's a moot point, right? Then there's the handoff woes. So how many people here in their system there is open source code? Right, all of you. That's the nature of software development now. And if each open source project is a black box or has its own special kind of tracing, you again lose that whole purpose of having end-to-end instrumentation and understanding of what's going on. So this was another reason why a tracing effort would be very onerous, both in terms of time, money, effort for a company. And then finally, even if some standards were there or instrumentation best practices, they were all very vendor specific, which is a huge risk for a large organization. We've been hearing from all the big company people in this conference, and they talk about how hard it is to, as someone was saying, shift the elephant. Now, if you're shifting an elephant and you're tied to the person who's shifting it, what if the elephant gets mad and you can't get rid of the person who's shifting it? That's really scary, right? I grew up in India, and my father is a forest officer, so I think this analogy makes more sense to me than you. So sorry about that. But anyway, the point I'm trying to make is that when you're making such a big effort, if you have no way out of a specific strategy, then it's very risky. What you ideally want is that if you instrument, you can then try out different ways to make things work for you and arrive at the best solution, which kind of goes back to the first auto instrumentation point, that every system is a special snowflake and needs its own solution. So this is where OpenTracing enters the story. Like, before we get to the OpenTracing spec, it will be helpful to understand a little bit of what led to it. We discussed the problems that companies face already, but if you think about the past, this is not a new concept, right? Tracing research has happened since the 70s. I know Brown University does a lot of work on this to date. They come to all the distributed tracing workshops that we do. And then Google faced the problems of scale with microservices much before most other companies, because they were seeing web traffic at an unprecedented level. So they broke out into services, and then they instantly started feeling that tooling problem. And some people, including Ben Sigelman, who's a co-author of the OpenTracing spec, built out Dapper at Google, which is Google's always-on distributed tracing system. Then they wrote a paper about this that got very popular, and based on it, all the forthcoming solutions for tracing were built, including Zipkin, which was built for Twitter, and then open sourced in around 2009. I am not 100% sure on the exact year. And that became sort of the de facto open source go-to for most people. And that's built exactly on the principles of Dapper. So here we were. And then as more and more companies started looking at observability solutions, though, they started hitting the problems that we were talking about in terms of instrumentation. So Ben Sigelman, who built Dapper, and then Adrian Cole, who is the lead maintainer of Zipkin, and a bunch of other industry people like Uber, Netflix, Bloomberg, et cetera, came together. And last year, they wrote out a spec that would make it so much easier for people to instrument their code base for tracing, find out where it provides value, and do that in a risk-free manner for the developer and the organization, as well as with support from open source. So that's a little brief history of where OpenTracing comes from. It didn't come out of vacuum. It came from years of experience and years of pain that eventually led to this. That by no means means that this is like a perfect done spec. We've released 1.0, but it's ever incremental. There are some big changes coming up in the API that will be soon announced, which I think you will be excited by. Anyway, so OpenTracing in a nutshell is a standardization spec for people who are looking at tracing. And it helps developers, of course, but it helps people who are managing running applications that are in production. Because it provides vendor neutrality, you can go to any different solution, build your own, whatever works, and you have that flexibility. It helps open source framework owners because suddenly they can help their user base have more visibility into the framework itself, debug their own problems without having to pick any sides. OpenTracing is a vendor neutral standard. There's no politics around it, so it's easier for them to make this choice. And then finally, the tracing and monitoring vendors out there, it helps them enable their customers because they're like, here's a risk-free way to get started. So everybody wins. So when we think of the OpenTracing architecture, it's important to know it's an API that sits in the middle that is talking on that is on one side. There is the actual application where there's the logic, the RPC framework, the other things, existing instrumentation. And then on the other side is actually the tracing systems, such as Zipkin, LightStep, Jaeger by Uber, which is just going to be open sourced. So the important thing here is that the API sits in the middle and provides the plumbing, sort of the pipes and the drains and the roads for data to be taken out of your system, but it does nothing with it. All the analysis, all the insights that you're going to get are going to come from the tracing solution. OpenTracing has no hand in that. So that's something important to remember. It's a no-op by itself, very unglamorous, unfortunately, but it is what it is. And what it does is it ends up augmenting traditional tools because the kind of data, as you can imagine, is very helpful when you're looking at logs, metrics, or doing critical path analysis. Now, I'm not saying that this replaces all your logging tools or your metrics tools. It means that you can send better data to these tools and analyze wherever you want to analyze, sort of your choice. And that's kind of why the open source community has really gotten behind this in the one short year of existence. So we went over the slide at the keynote, but Spring from Java changes the game for a lot of enterprises. gRPC is so great for anybody who has inter-process communication, and Ruby is new support. But these are just some of the examples, but there's a lot more. And as I said before, there's tons of vendors who are joining the bandwagon as well, because this is just good for everybody. There's a ways to go, but the starting point is feeling right to a lot of people. And that's the same reason why companies are risk-free using it. We've been through this, so whatever. Now, how many of you remember the Donut Salon demo from yesterday? Okay, about half. So for those who don't, do you guys mind if we just go over it again to demonstrate distributed tracing? Cool, awesome. So for that, I would like your help. Please take out your mobile phones and go to donutsalon.com, which is Donuts as a Service. This is my startup that I have built. It's experiencing hyper growth, growing really fast. It's built with microservices, but we're having concurrency issues. But we built it with OpenTracing. It was really smart. So let's go to donutsalon.com, please. I am going to do that too. And so you will see something like this. Please order as many donuts as you can to help create a success disaster. This will not be a disaster if you don't help, so click a lot. I'm relying on you. Okay, so we've done this. Perfect. Okay, so now let's see what is the architecture of this amazing startup of mine. I'm going to be a billionaire tomorrow. So basically, it's all bootstrapped. So it's a very simple system. We have a client, we have a server, and then we have a mixer, fryer, topper. All of these are built with OpenTracing. Now, the one thing I have done, which you might remember from yesterday, is that I've added these OpenTracing baggage tags. And what baggage does is the tag just follows through the entire trace. So, and I have done these tags for the type of donuts that we have, like sprinkles, cinnamon, glazed, etc. So this will tell me if there's an issue with a particular kind of donut. So now, let's see what the traces are going to show us about. Like, you might have seen that the response was kind of slow, and somebody said it crashed, which is exactly what I expected. So I'm going to look in Zipkin, which, as I discussed, was the open source solution of choice. What is the date today? Can anybody tell me? Sorry. 29? Okay, so this is correct. Okay, great. Sorry. No, the time is, okay, 4:35. Let's search. Okay, So we're seeing traces here. So this is what traces look like for those who have never seen them before. Oops. Surprise. So you will notice here, if people can see, that the fryer is taking up most of the time, right? It's saying 65%, 62, 69. So this tells me that the issue, the slowness, is in the fryer. So I click this, and here I can see more detail. This is Zipkin, guys, by the way. And I see what's going on. And this now so the point is that in one click, I knew this is the longest time that's happening in this transaction. Just to see the portability of the system, I'm going to go into another vendor, LightStep. Okay, this is what you guys did for the success disaster. So great job, people. It's like going all the way up, so I really appreciate it. Let me find a trace that I can actually click on. Sorry, I'm just going to refresh. Okay, I see a trace here that's like pretty high latency issue. All right, so here what do I see? Well, first I see that are people able to view properly at the end? Yeah, all good? Okay, great. So first I see here that the browser part, the web client, the mobile client in this case, is taking up a bunch of time in the beginning, right? And that's something, it's good to know because, I mean, you can't really do much about it right now. But then in the make donut, which is the majority of the main actual process, we see, again, just like what Zipkin told us, the fryer is taking up the most time. Now, there's a ton of more information which when you have time, you can go over. One thing I'll point out is like, this one, the logs here are telling me that the fryer's gummed up. It's like there's a log for 103 transactions, which is pretty bad. And like, the cinnamon is the problematic donut. So as you can tell, like what I'm trying to convey over here is that I clicked once, I got to this view, and instantly I knew the fryer was the problem, and then had more detail should I need it. That's a lot different than knowing there's an SLA violation, and then first like seeing, okay, where is the SLA violation? Okay, then what system do I go check out? Okay, well, where is the problem exactly? This is like click, 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 solve, problem solve. Well, not problem solved, problem identified. So that's the main thing I've been trying to demonstrate here. So, all right, let's go back to the presentation. So what we saw here with OpenTracing was we saw vendor neutrality, right? You saw traces at exactly the same time for exactly the same thing in both LightStep and Zipkin. The view is different, but that's a UI thing, not like vendor neutrality thing. Then you also saw like, how the microservices are interacting, what comes first, what comes next, what's the story. And then the baggage tidbit that I added was able to tell us why there was trouble. There was an issue with the cinnamon, and that was locking things up. So using these tools, people can beautifully scale out this visibility into the real world. So if you want to get hands-on, this is a plug, shameless, by the way. If you want to get more serious about tracing and do a tutorial, please come tomorrow to the distributed tracing workshop. It's A08, so across the hall at 2 o'clock. There, bring your laptop. We'll be helping each and every person go through a Go tutorial or a project of your choice in a different language. And for those who are already farther along, there'll be like kind of an unconference going on where we can talk about specific issues you're facing or just, thought exercises. So hopefully some of you will come there. And and real donuts, big selling point. So I've been talking donuts so much. People are coming up to me in the conference being like, hey, where are my donuts? Where are my donuts? But tomorrow I'll be able to actually offer real donuts. So it'll be good for me anyway. So now we move on to sort of the futuristic experimental part of this talk. So everything we've talked about has been about how auto instrumentation doesn't work. You need to instrument your system to what you need it to be, and then kind of take it from there. And that is the best approach in today's environment. But there is a thought exercise about potentially using Kubernetes to take away a lot of the work and do auto instrumentation across Kubernetes. So this is a really bad diagram I made literally today. So sorry. But so these are 2 pods, and there can be multiple pods, and there's things happening in each pod, and then that continues onwards. And the ideal scenario is that you get what we can call a depth over here, or intra-pod stuff, as well as breadth, as well as depth with the connections between 2 daemon sets or pods. So that would be ideal. Now, in order to get that, we need spans, which is tracing within the pod, and that's fairly straightforward because even if your application is not instrumented, if you use a proxy, like an L7 proxy, such as Envoy, Linkerd, these are sort of the popular ones. Linkerd is in CNCF project. Then you can get 1 span per request. And it's like something entered and went through the whole pod, and because there was a proxy right there, it spit out 1 span for the entire request. And this is without instrumentation, right? So that works straightforward. But then once that spans come out, how do you connect it to the next destination and the next, so that you have the full visibility? We've seen, actually in the OpenTracing world, we have seen large companies make this happen by doing their own instrumentation and figuring things out. So like Envoy does something that's actually an example of this. Feel free to check it out at your own time. But this can be standardized, and that's the future we're talking about, where you can use said L7 proxy, which is built with HTTP client library, to actually do the context propagation with the help of OpenTracing. So let me kind of try to help visualize this, because there's a bunch of words. So basically, the way it will work here is that this diagram hopefully helps explain, where you have an HTTP request come in, and then the OpenTracing context propagation piece starts with extract context. Then the application does whatever and sends out an HTTP request through the proxy. Now that created 1 span, right? We remember that part. But because we did extract already, the proxy injects the context, and then it forwards it to the next pod. And so you can use it in daemon sets or pods, whatever. And then you kind of rinse and repeat the process, and suddenly you have everything visible across your entire Kubernetes cluster. So effectively, all you would be doing, this is like 0 instrumentation, basically. You would add an L7 proxy, which has a HTTP client library paired with it. You make and receive HTTP calls. Because the L7 proxy has instrumentation for OpenTracing, you suddenly get the depth as well as the breadth. So that would be the entire picture. This is not true right now, but you could go home and try this. This is safe. But it's something that can be standardized. People are doing this in their individualized cases. I think the next step is to make it a standard for everybody, which would make people's lives a lot easier. It is something that OpenTracing is looking at very seriously in 2017 and early 18. But if people are excited about this, would definitely love to talk to you, either at the workshop or here after, because this will move the project and our mission of providing observability that can then lead to controllability much farther. And another shameless plug, if you want to get more detailed, please come to our workshop. There'll be mentors there, such as, I say your name wrong every time, sorry. Jurasi, as well as Ted, and a few other folks who are veterans in the tracing world, as well as Tom Wilkie, who was here before us, I think. So yeah, you should definitely check us out if you want to get serious about tracing. But if not, I hope this information was useful. And feel free to check us out on GitHub. We have a website and Gitter where people go and talk about their problems, etc. And you'll find folks from all walks of the 3 types of developers I talked about, such as providers of tracing solutions, open source projects, as well as application guys. So you'll find your ilk pretty quickly. Anyway, that was that. Thank you so much for your time. Let's definitely stay in touch. And I would like to invite Ted now on stage to help me with answering your questions, because he knows a lot more than me. So, guys, are there any questions out there? Sure. Oh, do you want to take the mic, please?
You in the back? talk about OpenTracing this morning, like,
Yeah.
more or less, like, I work with Apache Storm,
Hmm.
and Storm puts int64 ID, and then that traces the entire topology, and that's how it tracks tuples in the full topology. It's something similar, but for a widely applicable with a number of resources and stuff like that. Is it the right way to understand that?
Yes, that's
Yes,
correct.
perfect. Yeah, it's like it's across the whole system, like you said, Apache Storm, right? So which is like reliant on that. The idea is let's make that kind of visibility and more across your entire system, and across everybody's system, really.
And if I were to use it, what are the dependencies? Like, I went through the page of the region data, and it just says like for the Golang thing, you just add like one line, but then you're showing all this fancy UI and stuff like that, so that would be the server. And then what else? Like when you hit OpenTracing,
Right.
does it send some data on the server, or does it log to a file that is then read, or what are the dependencies?
So as I mentioned in the talk, OpenTracing is a no-op by itself. It's a way to port data into whatever situation system you want to take it in. That could be your homegrown solution, or it could be Zipkin, in which case you would need to run a server by yourself because that's how Zipkin works. And then,
If you're talking to a total move to OpenTracing, so
okay,
I don't know anything about OpenTracing or
Yeah.
Zipkin or anything.
Sure.
right.
I just want to know, like, even if I want to test it out, like, what all do I have, what hoops do I have to jump through, to get it?
Sure. Yeah, a simple test would be if you are open to using Golang, then there is a open source tracer called AppDash, which is really simple, and there is like Docker images available for it. If you want like a quick test, I would recommend that. And tomorrow in the tracing workshop, I think I should stand farther from that mic. In the tracing workshop, I think you'll be helping people connect to a tracer as well, right?
Yeah, so we'll be doing a walkthrough in Go tomorrow, and that'll be connecting to Zipkin, among other things. Just running Zipkin locally in a Docker image is really easy.
Yeah, definitely. And like there's documentation on the OpenTracing site about potential things you can do if you look at tracers. So that should help you, I hope. Another, yes?
Yeah, so if anyone's working on the .NET Core or
.NET Core. There is some momentum there, but it hasn't reached quite maturation. So we're actually like open to contributions because some folks have started work on it. It just needs to be better.
Yeah. Sadly, .NET always kind of lags a bit
Comes
with
last.
these new initiatives.
Yeah, for the classical .NET, I understand now that
Yeah.
we have the .NET Core, it should become better, right?
Yeah, definitely.
You had a question.
How does the OpenTracing working with sort of legacy logging, so like the log giant stuff, how does that interact? Is it replaced?
Do you want to take that?
Yeah, on its face, you can do these things totally separately, right? The degree to which you're just logging with Log4j. One potential thing, if you are trying to not touch your system, there's active work looking into doing out-of-band tracing, which means ingesting logs and turning them into spans and traces, the degree to which that information is in there. The other direction is, as you start instrumenting your application with OpenTracing, you'll notice that you're doing all the same logging against your spans that you would be doing in Log4j. And so you start doubling up your log points. So what I suggest to people at that stage is to make a OpenTracing Log4j bridge. So you rip out your Log4j logs in your application and do your logging with OpenTracing, and then have a Log4j tracer that's just teeing off and outputting it that way, if that makes sense. Yeah.
More questions?
This might be a totally banana idea.
Excellent. I love bananas.
There's also, this effort with Prometheus. And traces is obviously, or tracing is sort of somewhere between a metric, right? You got
Yes.
time series. Also with logging, right?
Yes,
Log data.
exactly.
Has anybody talked about like exposing like maybe a metrics endpoint from the tracing data that we're collecting in these sorts of tools so we can push that into like the metric stream that we have?
Right.
Yes.
So that's very straightforward to do. So OpenTracing is just an API, right? So it's an API you're using to instrument your code, and then separately, you're installing a tracer, like when you start your application. So it's pretty straightforward to create a tracer that is taking that information in and then creating metrics out and pumping them out into the system of your choice.
Well, so because Prometheus uses a full model, you actually have to fire up a server, or you have to have
Yes.
an endpoint there. Would that actually work with the framework that Open?
It does. Yeah, it does.
Just the previous talk Ted did, he kind of demoed
Yeah.
that. And there's actually on the OpenTracing site, there's a video about how to kind of,
Yeah.
there's a talk that like shows a demo of that,
And
which you can check out.
I have
Yeah.
to push a code change, but the walkthrough we're doing tomorrow, and that's up on GitHub, and I'll tweet it out. But there's a example Prometheus tracer baked into that. Yeah.
Yeah, it starts making, you're absolutely right that once you connect things like SLA metrics and all of that and the tracing data, that's when you see the real value.
Yeah.
And a lot of systems are now coming out about
Right.
that.
And, yeah, and I would say one thing you discover when you start doing it where it's all of your logging and other stuff is coming out of these OpenTracing API endpoints is now everything is sort of collated in lockstep. The degree to which you were sort of measuring something with metrics and sort of logging the same thing, but maybe not exactly in the same spot. Right now, that is all perfectly lined up with the same names for things. And so it becomes a lot easier to be like, you know, in your metrics situation, can I just click a button here and go to Splunk or my logging solution and see the same information in that system? It becomes a lot easier to do that.
And done rightly, it can actually save you a ton of money too.
Yeah.
So think about that. Yes?
In the donut example, you discovered it was the cinnamon donut.
Right.
The frying service. What's the next step after that? Do you need something like application profiling, monitoring to actually
Start making your
to
cinnamon
actually
donuts
start-
faster.
Let's talk about cinnamon donuts. What's the next step? Do you need another system, or is this something you can extend and add to OpenTracing?
That it would be great if it could figure out exactly what was wrong and then write the code for me and push the change. That would be awesome. But yeah, that's usually where the sidewalk
the
ends.
scope of
You
it.
have to,
Yeah.
at that point, you know.
Because what it has done for you is basically pick out the needle in the haystack where, okay, there were all these potential issues, this is the one, then the developer, DevOps person, whoever, goes in and fixes the problem. So it helped you to discovery, and then the fix is going to come from you. But what will impact it, though, is your understanding of how are all these services interacting. The donut example was a little too simplistic. But for example, like let's say one service is gumming up the resources, right? That is it because of that service, or is it because 5 services before that, there is some block there, right? That knowing the interaction of all the services is going to help you to the solution faster. But ultimately, it's going to come from you. At least all the systems we know of are like that. Maybe there's some special one that I haven't heard of yet. Anything else? All right. Well, thank you so much, everybody. And just a final reminder, make sure to come to the Donut Salon.